Well, cast your mind back to February last year and you may remember the excitement when NASA successfully landed its Perseverance rover on Mars.
The twin rovers Spirit and Opportunity found dramatic evidence. These are hematite spheres and they form in water.
It may not be long before we can convert the vast, barren expanse of Mars into a new Earth, a second world for our species to thrive. But of course, before any of that can happen, we need to know more about the red planet. Such efforts have yielded results in the form of the Spirit Rover. Over the span of 344 Martian days or sols, this reconnaissance robot defied expectations and outlasted its initial 90-sol life expectancy, overcoming significant software and hardware challenges that threatened to end the mission prematurely. Its dramatic entry into the Martian atmosphere, followed by a precarious landing on the planet's red desert, set the stage for an unforeseen mission. But most notably, Spirit Rover's last discovery has revealed water on Mars. Today, we'll tell this amazing story. Mars Unlocked. As part of NASA's Mars Exploration Rover mission, the Spirit Rover landed on Mars on January 4, 2004. Its arrival marked a significant milestone in humanity's quest to explore the red planet. After a fiery descent at a speed of 19,500 kilometers per hour, Spirit's airbag-cushioned landing system ensured a safe touchdown within Gusev crater, a site believed to have once held water. This location was chosen to investigate Mars's geological history and its potential for past life. Spirit's landing was celebrated globally as it opened a new chapter in planetary science, enabling unprecedented exploration of the Martian surface. Ever since, the rover's mission on Mars was nothing short of groundbreaking. Let's walk through some of its most groundbreaking discoveries. In 2007, Spirit made a stunning revelation during its time on Mars. It uncovered evidence of water in the form of a mineral called jarosite. This mineral, which can only form in the presence of acidic water, was discovered at the bottom of a crater Spirit had been exploring. The significance of this finding was immense, as it provided strong evidence that water, possibly in liquid form, once existed on Mars. Spirit's high-resolution images and spectral analysis of rock formations revealed this unique mineral, which could only have formed under specific environmental conditions, pointing to the possibility that Mars may have once harbored water, an essential ingredient for life. But this was only the beginning. We'll get back to the Martian water question in a bit. For now, let's move on. Spirit's first major scientific objective was to climb the steep slopes of Husband Hill, located within the Gusev crater, an ancient impact basin on Mars. This mission goal was not only a physical challenge for the rover, but also a key step in unlocking the secrets beneath the Martian surface. The rover had to navigate rough, uneven terrain to ascend the hill, which presented significant technical hurdles and pushed Spirit's engineering capabilities to their limits. As Spirit climbed higher, its panoramic camera offered breathtaking views of the Martian landscape while capturing valuable data that would later help scientists understand the planet's history. Spirit's successful climb provided scientists with a window into Mars's ancient history, as it exposed a series of layered rocks that had been deposited over millions of years, perhaps by ancient lakes or flowing water. But things did not end here. Over its operational lifespan, Spirit discovered evidence of volcanic rocks that suggested Mars had experienced significant geothermal activity in its distant past. One of Spirit's most exciting discoveries came from its analysis of the Martian soil, which provided scientists with vital clues about the planet's habitability. Spirit uncovered hints of ancient volcanic activity that could have created the ideal conditions for microbial life to thrive. The rover also captured detailed data on the planet's atmosphere, including the effects of dust storms on the Martian climate. Researchers speculated that conditions on early Mars could have been warm and wet enough to support microbial life, especially in environments where water could have been present in liquid form for long periods. These findings laid the groundwork for future missions, including those focused on searching for direct signs of ancient life, such as NASA's Perseverance rover. So, was there ever life on Mars? Could life have existed? And, most importantly, is Mars a potential destination for future human explorers? We'll get to these in the end. For now, let's carry on with Spirit's achievements. Year 1. Anniversary. and champagne rock. By January 2005, Spirit had far surpassed its initial 90-sol mission expectancy and was already celebrating a year of remarkable accomplishments. The rover had overcome early technical challenges, including issues with its software and power systems, to become one of the most successful robotic explorers on Mars. As part of this anniversary celebration, Spirit's scientific team focused on a unique rock formation on the slopes of Husband Hill, an area of significant geological interest. The rock was named Champagne by the team due to its bubbly, textured appearance. The rock's unusual texture and composition suggested that it might have been shaped by past volcanic activity, but what really intrigued scientists was the possibility that it had undergone significant alteration by water. Spirit's investigation of the rock included using several of its onboard tools to scrape, analyze, and study its composition. One of the first steps in Spirit's study of Champagne rock was to use its rock abrasion tool, or RAT, to expose fresh surfaces for closer examination. The RAT, a powerful tool mounted on the rover's arm, effectively ground away the weathered exterior layers of the rock, providing the rover with access to pristine, unaltered rock beneath. This allowed scientists to study materials that had not been exposed to the harsh Martian environment, such as wind erosion or the planet's extreme temperatures. The results from the RAT's analysis suggested that Champagne rock had been shaped by a combination of volcanic and aqueous processes, hinting at a more complex geological history than previously understood. Spirit's findings would later support the hypothesis that water, perhaps even in liquid form, had played a key role in shaping Mars's surface, much like it had on Earth. The microscopic imager, or MI, worked in tandem with the RAT. While the RAT exposed new surfaces, the MI provided high-resolution images of the rock's texture and features at microscopic scales. The images captured by the MI allowed scientists to identify tiny mineral structures and surface features, revealing details such as crystal formation and signs of past weathering. Another critical tool was the Alpha Particle X-ray Spectrometer, or APXS, which was designed to analyze the chemical composition of rocks and soil. By bombarding rocks with alpha particles and measuring the resulting X-ray emissions, the APXS could identify the elements present in the target material. This was essential for understanding the mineral content of Martian rocks, and it helped Spirit identify the presence of minerals like olivine, feldspar, and various sulfates, all of which pointed to Mars' potential for past water activity. The Mossbauer spectrometer, or MB, was another important instrument used to study the mineralogy of Mars. This tool, designed to analyze iron-bearing minerals, worked by measuring the absorption of gamma rays as they passed through the Martian rocks, providing precise information about the oxidation state and mineral composition of the iron present. The Mossbauer spectrometer helped Spirit's team confirm the presence of minerals that form in water, such as goethite and jarosite, reinforcing the idea that Mars had once been wetter and potentially habitable. Together, these instruments allowed Spirit to perform detailed analyses of the Martian surface. Spirit's perseverance and ingenuity also played a crucial role in unlocking the mysteries of the Red Planet during the rover's extraordinary mission. But it hasn't always been easy. Technical challenges and vulnerabilities. The harsh Martian environment, coupled with the rover's delicate systems, presented constant obstacles that engineers had to address. From minor electrical malfunctions to the gradual decline of its power supply, Spirit's journey was marked by an ongoing battle to maintain functionality and optimize performance in an unforgiving landscape. For instance, quite early on, engineers discovered a small short circuit in one of the rover's circuits. Although this was not immediately catastrophic, it posed an ongoing risk. The issue was identified early enough for the engineering team to implement a series of countermeasures. Engineers carefully calibrated the rover's power consumption, especially during periods when the rover's electrical systems were under stress. Additionally, Spirit's power and data systems were designed such that if one part of the system were compromised, backup circuits could ensure continued operation. But that's not all. While Spirit was equipped with solar panels to generate power, one of the most persistent challenges it faced was maintaining a stable power supply in Mars's unpredictable and often harsh environment. Spirit's ability to harness solar energy was significantly impacted by the buildup of dust on its panels and the seasonal fluctuations of sunlight on Mars. Mars's atmosphere is thin and dusty, with frequent dust storms that can blanket vast portions of the planet. These dust storms were an ongoing concern for Spirit, as they reduced the amount of sunlight reaching the rover's solar panels. While Spirit's panels were designed to withstand some level of dust accumulation, the rover's performance was still affected when dust levels increased, blocking sunlight and reducing the panel's efficiency. At times, the power levels became critically low, forcing Spirit to operate on limited energy. To address the power issues caused by reduced sunlight, Spirit's engineers developed strategies to maximize the rover's energy efficiency. They carefully optimized its operations to use power sparingly, prioritizing essential tasks such as communications with Earth, health checks, and data storage. During periods when sunlight was scarce, Spirit entered a low-power sleep mode, in which it would conserve energy by shutting down non-essential systems. This approach allowed Spirit to operate for longer periods, but it also limited its ability to conduct scientific experiments during these times. Despite these ongoing power challenges, Spirit's engineering team constantly adapted and found innovative ways to mitigate the impact of dust. In some cases, Spirit used its mobility to reposition itself on the Martian surface to expose its solar panels to areas with less dust accumulation. The rover's design also included heaters that helped prevent the solar panels from becoming too brittle in Mars' extreme temperatures, which helped keep them in functional condition despite the wear and tear from dust storms. By year 2 of its mission, Spirit's engineers began implementing additional measures to deal with the dust buildup. Spirit's wheels were used to sweep the dust off the solar panels by driving the rover back and forth over particular areas, using the rover's movement to dislodge some of the dust. Despite these power-related challenges, Spirit continued to operate long after its expected lifespan. It exceeded expectations by surviving multiple Martian winters and providing unprecedented scientific discoveries, all while battling the limitations imposed by dust and sunlight. Unexpected discoveries that changed everything. One of the early landmarks in Spirit's exploration was its path to Larry's Lookout, a site chosen for its strategic view of the surrounding terrain. Along this path, Spirit encountered 2 rocks, dubbed Peace and Alligator, each featuring intriguing features such as ridges and layers, which raised questions about the planet's geological history. Peace Rock, located relatively close to Larry's Lookout, was one of the first to be analyzed in depth. Analysis revealed that the rock was made up of basaltic materials, similar to those found in volcanic rock formations on Earth. Just a few sols later, Spirit encountered Alligator Rock, a formation with deep, grooved textures that suggested erosion had played a significant role in shaping the rock's appearance. This indicated that liquid water, or perhaps wind, may have played a role in the rock's formation. The patterns on Alligator Rock, resembling the scales of an alligator's skin, led us to believe that Mars may have undergone erosion processes similar to those on Earth. Spirit also stumbled upon a region known as Paso Robles. This area, located near the rover's extended path, proved to be a treasure trove of geological surprises, particularly with its discovery of salt-rich soil. The soil in this area was rich in magnesium sulfate salts, compounds that on Earth are typically formed in the presence of water. These salts, including hydrated forms of salts like kieserite, were detected using Spirit's spectrometers and infrared tools. This discovery suggested that liquid water may have been present on Mars in the distant past, long enough for these salts to form and accumulate. More importantly, the presence of these salts could imply that Mars had once experienced a wetter climate. The discovery was unexpected, as scientists had previously believed that the Martian surface was too arid and inhospitable for water to persist in any form for extended periods. We're not done just yet. After more than 160 sols of painstaking travel across the rugged Martian landscape, Spirit finally reached the summit of Husband Hill. This journey was not without its difficulties. Spirit faced steep slopes, rocky terrain, and mechanical challenges. However, the summit provided a prime vantage point for the rover, offering an opportunity to capture some of the most detailed images and panoramic views of the surrounding terrain. Upon reaching the summit of Husband Hill, Spirit wasted no time in taking a comprehensive panorama of the surrounding area. The rover's cameras captured a wide-angle view of the Martian landscape, giving scientists on Earth an unprecedented look at the geological features that lay ahead. The images from the summit provided a bird's-eye view of the region, including the vast plains and rocky outcrops that Spirit had traversed over the past months. This panoramic data was crucial in helping scientists map the rover's trajectory and identify promising sites for further exploration. Spirit's summit position also allowed it to gather important data on Mars' moons, Phobos and Deimos. These two moons, which have intrigued scientists for years, are irregularly shaped and have highly eccentric orbits around Mars. Phobos, the larger of Mars's two moons, was found to be orbiting dangerously close to Mars, and it is expected to impact the planet within the next 10 million years. Spirit helped provide more detailed views of Phobos, capturing images that revealed its surface features, such as craters and grooves, caused by the constant bombardment of meteoroids. Scientists were particularly fascinated by the moon's irregular shape, which differs greatly from the round, spherical forms of most moons in the solar system. Phobos's peculiarities also led some to believe that it may have once been a captured asteroid, while others suggested it could be a remnant of Mars' early history. Deimos, the smaller of Mars's moons, is much farther from Mars. With its heavily cratered surface and irregular shape, it is thought to be a captured asteroid or debris from a past impact event. Spirit gains independence. Initially, all operations of the rover were tightly controlled from Earth, with mission planners making decisions about when to upload images, conduct analyses, or move to new locations. However, as Spirit's mission evolved, it became clear that the rover's capabilities were far beyond what was originally anticipated. With a series of software updates and innovative programming, Spirit was granted partial autonomy, allowing it to make independent decisions about its activities. By incorporating sophisticated decision-making algorithms, the rover was able to autonomously assess its surroundings, prioritize tasks, and determine when it was most efficient to upload data or activate its scientific instruments. This upgrade was particularly crucial given the rover's increasing distance from Earth and the time delays involved in communicating with the mission control team. The software updates were designed to optimize Spirit's ability to operate without needing constant instructions from Earth. One of the most significant advancements in Spirit's autonomy was its ability to decide when to take images, which was critical for gathering detailed geological data. Instead of relying on Earth to command the rover to capture photos, Spirit's onboard software could analyze the terrain, assess the importance of nearby geological features, and determine the best moments to deploy its cameras. This autonomy was particularly important when Spirit was exploring remote or hard-to-reach locations, where the time it took to relay commands and receive responses could hinder the rover's ability to gather useful data. Spirit also gained the ability to extend its scientific instruments, such as the rock abrasion tool or the Mersbauer spectrometer, on its own accord. This allowed the rover to conduct scientific analysis without waiting for further instructions, which was vital for taking advantage of fleeting opportunities, such as when the rover encountered interesting rock formations. Spirit's growing independence was on full display during its analysis of Comanche rock, encountered during its journey through the Columbia Hills. Upon closer inspection, Spirit zeroed in on the presence of high magnesium iron carbonates. This finding suggested the past existence of water on Mars. The discovery of these magnesium iron carbonates was crucial because such minerals are typically formed in neutral to mildly alkaline environments, often as a result of interactions between water and rocks. By being able to make its own decisions about when to deploy instruments and gather data, Spirit became an invaluable tool for understanding the planet's past, particularly its potential to support life. Further discoveries. One of Spirit's most important contributions to Martian science came through its study of the layered rocks at home plate. The rocks in this area were stacked in distinct layers, indicating a long history of geological processes that may have involved the movement of water. As Spirit analyzed these layers, it found mineralogical evidence suggesting that the region had once been shaped by past water flow, perhaps in the form of ancient rivers, streams, or shallow lakes. The most compelling evidence came from the identification of minerals such as clays and sulfates, which are known to form in the presence of water. This discovery was significant for several reasons. First, the layering of rocks suggested a long history of environmental changes, providing insight into the geological processes that shaped the region over time. Second, the minerals Spirit identified were not only indicators of water, but also a potentially habitable environment. For example, clays form when water interacts with certain types of rock, and sulfates can form in acidic waters, both of which may indicate a history of conditions that could have supported microbial life. These findings added to the growing body of evidence suggesting that Mars had once had a much more Earth-like climate, with stable, long-term bodies of water. Not only this, these environments could have even been conducive to life. While Spirit made significant scientific strides at home plate, the rover's journey was not without obstacles. A significant problem arose with Spirit's right front wheel, which began to show signs of failure due to the harsh Martian terrain. The malfunctioning wheel hindered Spirit's ability to navigate, forcing mission planners to reconsider the rover's course. The decision was made to divert Spirit to a location called Low Ridge Haven, which offered more favorable conditions for surviving the winter. This site was chosen not only for its scientific potential, but also for its relative safety in terms of solar exposure and ease of navigation. The wheel failure was particularly problematic because Spirit was already far from Earth, and the time delay in communication meant that immediate fixes or adjustments were impossible. As a result, mission planners had to rely on careful analysis of the rover's conditions and design a new strategy to ensure its continued function throughout the cold winter months. Despite these challenges, Spirit continued to adapt and operate. The shift to Low Ridge Haven marked a critical turning point in the mission, as the rover's mobility was restricted, but its scientific instruments remained functional. This phase of the mission highlighted the delicate balance between the rover's scientific ambitions and the practical realities of surviving on Mars, where unpredictable challenges often threatened to derail progress. While winter posed a series of challenges, Spirit still managed to make valuable discoveries during this time. Among the most fascinating were the rover's observations of potential Martian meteorites, which provided insights into the nature of the planet's surface and its history. These meteorites also helped scientists calibrate their instruments and refine their understanding of Martian geology. Spirit's images of potential Martian meteorites, particularly the Zhongshan and Allen Hills meteorites, were among the mission's most significant finds. These meteorites were of particular interest because they were suspected to be remnants of objects that had crashed into Mars, potentially from the asteroid belt or even from outside the solar system. By analyzing their composition, Spirit was able to gather data on the planet's impact history and its geological makeup. The iron meteorites also provided an opportunity to calibrate Spirit's scientific instruments, ensuring that the rover's measurements remained accurate. The meteorites found by Spirit shared several key characteristics with meteorites found on Earth, particularly in Antarctica. This discovery sparked curiosity among scientists, as the similarities between Martian meteorites and those found on Earth could offer clues about the nature of Mars's early history and its connections to Earth. Some researchers speculated that the meteorites might contain traces of organic material, which could provide further evidence of past life on Mars, or help identify the building blocks necessary for life to emerge. But that's not all. Meteorites found in Antarctica, such as the famous Allen Hills 84001 meteorite, have long been the subject of research for potential signs of life, as they contain mineralogical structures that some scientists believe might be fossilized bacteria. If meteorites from Mars also contained evidence of life, it would suggest that Mars was once habitable, and that microbial life may have existed there. These meteorite discoveries helped guide future missions to Mars, particularly those focused on returning samples to Earth for closer examination. However, what came next was even more unexpected, and exciting too. During a routine exploration of the Martian surface, Spirit's malfunctioning wheel stumbled upon a patch of bright white silica, a mineral known for its association with water. The discovery was unexpected, as the area was not previously considered to be a likely candidate for such a find. The silica, which appeared to be in the form of fine deposits, was especially important because it is typically associated with hot spring deposits or geyser-like environments on Earth. These environments are often rich in life. The presence of silica suggested that liquid water had once flowed through this area, possibly forming in springs or pools. The white color of the silica suggested that it had been deposited in a highly acidic environment, which could have been associated with geothermal activity. This discovery provided further evidence that Mars once had the conditions necessary to support life, at least on a microbial scale. But wait, where is water on Mars now? No, it is not gone. The most significant reservoirs of water on the red planet are located in the polar ice caps. Scientists have also detected subsurface ice across various regions, particularly in the mid-latitudes and high latitudes. This ice lies just below the surface and is thought to be relatively pure in some areas. On top of this, seasonal flows known as recurring slope linii have been observed on Martian slopes, hinting at the possibility of transient liquid water. Additionally, some scientists believe that there's a subsurface lake beneath the South Polar ice cap. However, its composition, whether water or not, is still debated. On top of this, the Martian atmosphere also holds a minuscule amount of water vapor. Exciting, right? So, what about the Spirit Rover, and what can we expect in the coming decades? Spirit's legacy and a vision for the future. Over its long lifespan, Spirit not only endured countless technical failures and environmental obstacles, but also contributed groundbreaking discoveries that reshaped our understanding of the Red Planet. Despite Spirit's initial design as a 90-sol mission, it far exceeded expectations, lasting a remarkable 2,258 sols. During this extended mission, Spirit navigated treacherous Martian terrain, experienced power shortages, and confronted unexpected mechanical failures, including a malfunctioning front wheel that eventually hindered its movement. Yet, Spirit's ability to continue operating in such harsh conditions proved the durability and adaptability of its engineering. The rover helped us uncover the mysteries of Mars, take scientific measurements, analyze soil samples, and send data back to Earth that would inform decades of future exploration. Spirit's continued operations, even after its mobility was severely limited, were pretty impressive. The rover was initially intended to be a short-term asset to conduct basic geological surveys of Mars's surface. Yet, due to a combination of engineering brilliance and unexpected luck, it managed to outlast all expectations. Spirit's scientific legacy is rich with key contributions to our understanding of Mars. Through its investigations of various Martian sites, Spirit helped uncover the planet's past, providing critical evidence of past water activity. Moreover, the rover's journey is a metaphor for how scientific exploration, even in the face of seemingly insurmountable challenges, can continue to yield transformative results. Spirit's legacy lives on in the memories of those who followed its journey. It inspired a new generation of engineers, scientists, and space enthusiasts to pursue careers in space exploration. The rover's journey not only contributed to the study of Mars, but also fostered a sense of collective hope. Its mission also set a blueprint for future space exploration, particularly in terms of how rovers should be designed and operated. Spirit proved that adaptability and innovation in mission planning are as crucial as the technology itself. Mission planners, engineers, and scientists learned valuable lessons about how to design and operate robotic vehicles in the unforgiving environment of Mars. Its experience also helped shape the strategy for long-duration missions to other planets, including the idea of extending the operational life of robotic explorers beyond initial expectations. The rover demonstrated that with the right adjustments, even a vehicle facing severe technical challenges can continue to perform valuable scientific work for years. The mission's ability to evolve based on circumstances also set the stage for the next phase of space exploration, where missions can be more flexible and responsive to unexpected changes. Spirit's success also sparked the realization that space missions do not have to be limited to short-term objectives. The rover's extended mission, which lasted more than 6 times longer than initially planned, helped redefine the scope of future space exploration. In the years since Spirit's mission ended, its legacy has only grown stronger. Its contributions to the field of planetary science were monumental, and its perseverance in the face of adversity continues to inspire the world. Spirit's journey remains a powerful reminder of the value of exploration, both in space and in life. Just as Spirit's mission faced its share of challenges, so too will future missions. but the lessons learned from Spirit's time on Mars will continue to guide the exploration of the Red Planet for many years to come. Ultimately, Spirit's journey exemplified the spirit of discovery, resilience, and adaptability that defines all great explorations. Whether it was braving the harsh Martian terrain or providing groundbreaking insights into the planet's history, Spirit's mission was a beacon of hope for space exploration. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.